Section 1.6, number 32. We're given f of x is x squared plus 1, and g of x is x minus 2. And in this case, we're asked to find f over g of t plus 2. Okay. So in this case, what I'm going to do is I'm going to break it down into pieces. First, I'm going to find f over g of x, which is going to be f divided by g, right? F divided by g. And then I'm going to take that and then translate that f over g of t plus 2. All right, let's do the first step first. What is f over g of x? Okay, it's f of x, which is x squared plus 1, over g of x, which is x minus 2. Okay. Then I'm going to replace x everywhere with our t plus 2. So f over g of t plus 2 is going to be equal to quantity t plus 2 squared minus 1 over t plus 2 minus 2. All right, now we could leave it like this, or we could ask the question, can this be simplified? Okay, if we square out our t plus 2, this is t plus 2 times t plus 2. So it's t times t is t squared, 2t plus another 2t, so that's going to be a 4t, and then 2 times 2 is 4. Okay. So on the top, we're going to have our t plus 2 squared is going to be t squared plus 4t plus 4 minus 1. On the bottom, it's going to be t plus 2 minus 2, right? Since this is simply subtraction, we're not squaring anything, the plus 2 and the minus 2 will cancel out, leaving just a t on the bottom. We also have a 4 and a negative 1 on the top, and that will cancel out, leading to f over g of t plus 2 is going to be equal to t squared plus 4t plus 3 all over t. And this cannot be simplified anymore, right? We have this t on the bottom, so when t goes to 0, this thing is either going to blow up or it's going to have a hole. We can look and see what the graph looks like. In fact, let's do that. Well, this is what it is. Okay. Now let's look at the graph. In our first graph here, I'm going to show x squared plus 1, that's our parabola. Our x minus 2 is our linear that has been shifted down by 2. And this is our f over g of x. Okay, we get this thing that it's going to blow up at x equals 2. I wrote that wrong. That is, of course, a minus, right? Okay, this thing is going to blow up at 2 because we're dividing by 0 when x is equal to 2. If we look at our x minus 2 is 0 at 2. That means that 0 is on the bottom at 2. X squared is 0 on the top at 1, at negative 1, right? Our x squared plus 1 is a 0 here and a 0 here. So if it's a 0 on the top, it's just 0. If it's a 0 on the bottom, that's a blow up. In this case, it's a vertical asymptote. It's got to be a hole or a blow up if there's a 0 on the bottom. Okay, so that gives the f over g of x. That was our first step. In the next step, we replace x with t plus 2. Okay, now I'm going to treat it as x plus 2. That way I can graph them on the same graph. Remember the x plus 2, the plus 2 means that we take our function and we're going to end up shifting it to the right, right and left by 2 units. Okay, everything's going to be shifted to the left. So let's look at that graph. Okay, the black is going to be our t squared plus 4t plus 3 over our t. Okay, now this is our previous graph, our x squared minus 1 over x plus 2. Okay, and the key is that we went from an x to a t plus 2, and the plus 2 is going to take everything and shift it to the left by 2 units. It's also going to shift our asymptote. Okay, our asymptote was up here at 2. That also gets shifted to the left 2 units. Okay, so this black is our final function in terms of graphing this t.